And good afternoon, everyone. Thanks for jumping on with us today. My name is Zach Allison. I'm the ATS Market Development Team Lead here at ATS. Basically, our market development team kind of works as account managers for the various engineers and architectural firms that utilize our ATS SpecTool services across the North America. With me today is one of our great manufacturers, Dobbin, well, more than one manufacturers, but today we're
Yes.
in Sloan. Dobbin Sales has been a partner with ATS and our plumbing specification software for going on 3 decades now.
Long before it was software.
Yeah, it's been a while. But today we're here talking more about Sloan. For those of you that maybe this is your first ATS University session, we host almost weekly a webinar that can range from anything like today, a deep dive on an application, maybe a more focused dive into specific products, or even a more systems and software kind of code focused discussions as well. I'll show you at the end of the presentation how you can find all of our previous recordings and how you can access some of the information that we're talking about today on our free ATS SpecTool software. But the most important part today is to dive into K-12 and higher education facilities. And we've got Will Vandenberg here from the Dobbin Sales team. Will's been with Dobbin Sales, I guess, probably coming up on 10 years, nearly 10 years
Let's
now.
do a decade now.
Yeah, let's say a decade, just about there. Variety of roles, but really focused on, I think these days working more focused on like high-end products, a lot of the deep dives into specific applications and more kind of project management side versus just say, here's an account or here's a product.
Yeah.
So I'll let you give any more detail about yourself that you wish to, but with any other,
Sure.
I'll pass it over to you.
Awesome. Thanks, Zach. I'm really excited to be here today. The ATS opportunity gives us a chance to speak to people right across the country on a number of topics. And today that's specifying plumbing fixtures for K-12 along with higher education, so into colleges and universities. Like Zach mentioned, my name is Will Vandenberg. I've been with Dobbin Sales almost 10 years. For the last 5 years, I've really been focused on the products that sort of fall into what we consider the architectural and design phase. So those products that might be a little bit more upscale, more geared towards a more customized, a higher end washroom design, but I certainly cover the whole gamut from the high end facilities right on down through your average elementary school.
And just before we do dive into the actual presentation itself, I know you're going to cover it shortly, but we have a couple of questions coming in already from the chat
For sure.
regarding the AIA CEU aspect of this. So we'll be sure to have the list of attendees sent over to the Dobbins and Sloan teams. They'll be sending out certificates for your self-reporting after the presentation.
Yeah, thanks. You actually jumped to my next slide because I always do cover that before we dive in. So
Perfect.
This course itself is AIA accredited. Obviously, that's out of the United States, but it's something that's accepted in all the provincial bodies across Canada. It also carries an IDCEC if anyone's an interior designer on the call, along with Green Build continuing education as well. One of the things to keep in mind, if you hold a professional designation and a Green Build designation, you're able to double dip. So you'll be able to submit that certificate from today's presentation to both of those bodies to get your CEU hours from them. After we complete, Zach will give me that list of email addresses, and then you're going to receive an email that's automatically generated from our recording team that looks after our CEUs on the Sloan side of thing, and they will send out directions on how you can get your certificate downloaded, and then you guys know your procedures for reporting them as appropriate. One of the things to discuss before we jump into the CEU is that continuing education classes are intended to be education and not necessarily product presentations. We'll acknowledge the elephant in the room that everything in this presentation is a Sloan product, and I'm happy to talk to you about the specifics of those products after, but throughout the presentation, we'll just be talking generalities about the applications and the products that you have available so that we can sort of keep to the spirit of education. In terms of housekeeping, Zach's going to be monitoring the chat. He'll interject if you either use the raise hand function or the chat window, and he'll get my attention, and we can answer any questions as we go along. So let's jump in. Designing washrooms in educational facilities do come with some pretty unique challenges. A lot of those, revolve around the types of people that are using them, particularly kids and kids that like to vandalize things, along with facility managers that have to take care of a wide number of buildings over a large area. So we'll take a look at the different concerns that different sort of educational facilities have, and ways that we can make those washroom designs a little bit more applicable to the users who will be using them, along with the facility management teams that have to look after them. So there's really three core areas that we're going to talk about today. We'll first look at the factors influencing design in K-12 facilities, really the meat of most of the public and Catholic school facilities right there across Canada, along with product preferences that we tend to find from facility management groups. And then we'll move on to higher education. We'll look at how universities and colleges can have a slightly different approach to their washroom design, with some different priorities than you would have in a K-12 setting. And then we'll look at some of the products that are specific in terms of things like electronic sensors, low flow, dual flush, bringing that sustainability discussion onto the forefront. And then some of the other opportunities like solar and turbine to contribute to water savings throughout your designs. So let's jump in with K-12 washrooms. Really, all of the washrooms that we talk about in this presentation, we will consider to be high traffic commercial washrooms. So they'll have a lot of the same design challenges that you would find in a sports stadium, an airport, any sort of a transportation hub, along with a high school, a K-12 school. K-12 school washrooms see hundreds of visitors a day. Vandalism is particularly common. And if you talk to any school administrator, they'll tell you that grades 6 to 8, those middle school range, that's the worst stage for vandalism in a school washroom. Students will leave water running, they will clog toilets. So there's a lot of challenges that happen in those K-12 schools that we have to sort of design and work towards providing the best functional washroom. Washrooms are really considered a reflection on the school itself. School administrators, they have a saying that if you want to feel the pulse of the school, you need to go into the washroom itself, because that will tell you really what the atmosphere of that school is like. If you find a clean washroom, clean floors, all the fixtures functioning properly, that's a pretty positive reflection on the school. But you'll see neglect as well. You'll see areas of vandalism, taped off stalls, urinals that are taped off that can't be used, and those lend to a feeling of a lack of safety and a lack of student performance, because the students don't feel at home, they don't feel comfortable in their schools. So when we start designing and considering washrooms, that's a factor that we really have to keep in mind. There is a direct correlation between academic performance and the school conditions themselves. So when students are comfortable, happy, healthy in their schools, they do perform quite a bit better academically, because poor indoor conditions lead to things like distractions and health issues, particularly health issues in terms of bacteria that might be spread throughout a washroom to the students, or possible foodborne illnesses as well that can be transferred by touching plumbing fixtures. And when you improve that environment, you enhance the learning opportunities for the students. It's well documented that they result in higher test scores and better attendance for the students. And I mean, we all saw during the last 3 to 4 years that spreading germs through touch and different touch surfaces is something that is, we do our best to try to reduce, which is where the sensor faucet technology has really aided us. Also, in terms of that, a proper washroom should be designed so that it's easy to maintain, because that's the chief concern among the facility management teams at these schools and their janitorial staff as well. So some of the criteria that we look at when we talk about what makes a high performance washroom, We would expect them to have hygienic plumbing fixtures. Those are the sort of plumbing fixtures that can operate with minimum interaction between the user and the fixture itself, and possibly materials that help prevent bacteria growth on them. Water fixtures should be conserving water. There's really no reason now to be designing facilities with extremely high flow rates on the plumbing fixtures, because we're able to achieve comparable performance with significantly less, and sometimes 75, 80% less water than we have historically in the past. So we should have water conserving plumbing fixtures. Also a degree of forward thought into the design. So um, those technologies should be incorporated or have the possibility to be incorporated into existing buildings during retrofits. So not just new construction opportunities, but something that allow those facilities to be improved and advanced throughout time. And the highest priorities for high performance schools are the health and safety of the students and reducing the cost for the operators of those buildings. Many school districts will have limited budgets. So they want to be able to design functional washrooms that are also economical. We also, though, do see sort of a misunderstanding or a misbelief that modern washroom technology is actually more expensive and costs more to maintain down the road. And what we found actually is that modern high performance washrooms are much, much cheaper to maintain over the life of the building. Energy efficiency and water efficiency together go to reduce operating costs. We've seen projects in Ontario, for instance, where we've been able to so drastically reduce a private school's operating costs just through the water consumption alone, that they were able to pay for the upgrades that they made to 3 buildings on their private school campus within, I think it was 2 or 3 years, just based on the water savings alone, because water rates continue to increase right across Canada. Public schools, we tend to see rushing to the lowest cost, the lowest price bidder, because they have very limited budgets, and they need to be able to spread that right across the entire board. So in the case of a public school system, it's typically the lowest cost product that wins, whereas private schools tend to have larger budgets. So there's an opportunity there to design washrooms that are a little bit more cutting edge or a little bit more forward thinking in terms of sustainability when dealing with or engaging with private schools. As an aside, we find that older public school systems tend to have a very large install base. So one of the things that's important to them is product that matches the product that's in their facilities already. So typically what we'd see in most public school washrooms, very common products are manual flush valves because they're inexpensive and easy to maintain. A lot of times we will still see manual metering faucets, which are those mechanical faucets where you activate them. They run for a set amount of time and then they shut themselves off. And some pretty standard or pretty basic accessibility fixtures and accessories. K-12 schools, we typically find, are very reluctant to step outside those traditional manual faucets because that's what, for the most part, the facilities people are used to maintaining. They've done it for decades. They want to continue to do it going forward. What's interesting, though, is that being mechanical devices, they're quite prone to failure before some of the newer technologies, particularly sensor-activated flush valves. If you've seen the abuse that most flush valves take in public settings where they're typically kicked or, they're typically kicked on the handle, which over time can pull that mounting bracket loose from the wall, causing damage there. And then the faucets, likewise, being mechanical and spring loaded, they're prone to failing much more frequently than a sensor activated faucet would be. So the sensor activated flush valves take away that kicking opportunity for the user. So we find they tend to flush more predictably, more regularly. As well, there's options that can be set up so that they flush that bowl on a regular basis so that The waste is kept clear, or the fixture is kept clear. Traps and urinals, for instance, are kept filled, particularly during the summertime months. And then faucets as well. That robust sensor and solenoid combination that's activating on a regular, predictable basis um, tends to lend to much longer, much more reliable performance, which in turn leads to a reduction in maintenance for the facilities people. So slightly more upfront cost, perhaps in installing sensor activated technology, but over the life of that washroom, they certainly reduce the overall maintenance load that the facilities would find.
And just on that manual metering aspect, because I know there are still a number of boards that will include that on their output spec.
Yeah.
But you mentioned the difference in potential maintenance and the possibility for failure. That's not the first time I've heard that. One thing I'm curious about is like, what is it about the metering cartridge that maybe makes it a little bit more prone to failure than say even a manual single lever?
Um, let's see. There's probably a couple of different things at play there. The first, they take a fair amount of force to activate, so frequently they're slammed or pressed firmly. So in some cases, I know where we've seen the that top lever activator, depending on the model that's out there, that top lever begins to break down over time and eventually fail. Um, they rely on that spring maintaining tension throughout. When that spring loses its tension, it no longer operates, and then typically on top of that, when they do fail, they fail in the on position, so they continually run, costing a whole lot of water from that aspect.
Yeah, that could
Um,
be a big potential for insurance issues if
for
someone
sure.
fails the faucet and then plugs the sink.
Yep, absolutely, which we see with manual faucets as well. Kids love to do that. They love to plug sinks and run faucets and washrooms. But there was one
And
more thing I was
sensor ones,
thinking.
they fail close, is that correct?
The sensor ones will fail closed, and they will also have a run-on protection in them as well. So if that faucet is for some reason running on for a long period of time, it'll shut itself off after 2 minutes typically. So there's a flood protection aspect there.
One
There
thing
was
as
one
well I
more.
wanted to just kind of, I guess, highlight or get your insight
Yeah.
on as I've started to see some of the boards update towards, sensor activated, they may still include in their language the requirement for like a cycle time.
Yes.
Is an option like, instead of just having your hand in front of the sensor. Is it the same faucet? Is a different faucet that includes that cycle time?
So in some faucets, you're able to program them so they operate with a set cycle time. Typically, 20 minutes would be the norm, or sorry, 20 seconds would be the norm.
Yeah.
But we found when there's high traffic times, you're able to shorten that to 10 or 15 seconds. That actually helps move people through the washroom more quickly. So an adjustable cycle time is a great benefit when you have a particularly busy washroom.
Yeah, we're not doing a healthcare facility. We don't need the 20-minute run. Although that was helpful for a hospital project I was working on just a couple of weeks ago, where a similar sensor operated faucet, they can do like the 10-minute runtime purge. And if you're interested in that and you haven't attended our healthcare ATS University, please feel free to go watch the previous recording.
Yes. Yeah, the healthcare and the hospital world has no care for water conservation for very different reasons, and they're quite valid. So, um, where are we here? So, budget and maintenance considerations. Facility managers are typically the key voice in selecting products in elementary and high schools, because they're faced with maintaining them every day, particularly on large school board facilities, and their goals tend to be reliability and efficient maintenance. Um, they may not realize that some of those new products that are out there are able to improve both reliability and efficient maintenance. So that's really a conversation that you need to have with the facility management group when they're so married to past historic ways of doing things, and not realizing that new technology can make both of those goals much more readily attainable. Water conservation is typically not their concern. So because they're not responsible for paying the water bill, the facility managers are typically not interested in water conservation. To the point where I know one of the school boards in southwestern Ontario continues to use, even on new properties, um, um, regular flushing cistern type urinals, where those urinals will flush every 20 minutes, regardless, all year round, because they're convinced that they know from their historical experience that that is the most effective way of keeping those urinals clear and operating. They would rather see that than any kind of water conservation effort. And as we were just talking about there, so high efficient plumbing fixtures and electronic products are very, very common throughout the commercial space now. It's a great opportunity to introduce them into educational designs because it's a product that will help both in the water conservation sustainability side, along with making the facility managers' lives much, much more easy. Some of the places where you're going to see washrooms in K-12 specifically, you'll see them in student restrooms, student washrooms. They tend to be much more robust and vandal resistant. Also, teachers' lounges where you can be a little bit more progressive in your design and perhaps not worry about vandalism quite as much. Also, locker rooms. Some schools that will have food service kitchens, which are becoming more common with food programs being rolled out to school. Older buildings tend not to have them, but a lot of the newer designs, even in elementary schools, are now including kitchen areas for food programs. And then often sinks with integrated faucets and soap dispensers, sort of that multi-station, that wash fountain type design, are really, really great to use in a K-12 school. But now moving them into a modern type product that uses sensor technology and solenoid technology. So again, you're not relying on some of the older style that have, for instance, pneumatic operated valves where you use a foot pedal or something like that to activate. If you're using a multi-station lavatory or wash basin, you're able to go to a sensor technology, which really improves vandal resistance, attractiveness, and the reliability of that product over its life.
And
Case study. Yeah,
those foot pedal options also have an accessibility drawback to
they
it.
sure do. Yeah. Yeah, the foot pedal ones are not at all accessible. And in fact, a lot of the push button wash fountain ones are not accessible either because the push buttons are too small to meet the area that's required to press on them. Quick case study, just to this one happens to be in the United States. It's Corning Painted Post, which is in Corning, not too far from Elmira, New York. If you're ever down in the Finger Lakes area. This is their student washroom, which they had the opportunity to renovate this entire school. It's a joint elementary and high school together in the same facility. One of the things they went to was that this long linear trough look, and we'll see in a second here, combined with sensor activated faucets so that they could eliminate that touch of the faucet, because that is typically the most germ infested area of a washroom is the manual faucet. One of the things they did is in the washrooms themselves, they used a battery operated sensor flush valve. That way they didn't have to run new electrical to all of the different washrooms in the in the school, because it was a retrofit scenario. And then they use a turbine powered sensor faucet. So those faucets are generating their own electrical power. Also great for a retrofit situation because you don't need to run electrical. And with that turbine, they're generating the water to run that faucet all year round. And then the sink they used was a trough style, which is becoming very, very common because they allow for very easy cleaning from a maintenance or a janitorial perspective. So they're able to clean that entire wash sink, that entire sink surface quite quickly and easily. Moving into higher education now, a few more options that are available for you from a design perspective. You have many of the same maintenance considerations that you would have in a K-12 school, but now there's a little bit more flexibility in terms of the design. Typically they have things like student centers, lecture halls, dormitories, a broader scope, larger cafeterias, larger food service areas. Um, and not as common in Canada, but some our schools certainly have larger stadiums for their students, and larger gym facilities as well. So more of an opportunity or a broader scope of design in higher education. We typically find that they have higher budgets, so that also allows for a more creative design. We're not so much interested in white fixtures and chrome anymore, but now there's an opportunity to involve some different ideas and some newer design opportunities. In a lot of cases, they'll have their own design team in-house to handle the smaller type projects. I know that we've worked with a number of universities around Toronto that have done small jobs where their own team in-house takes care of it. And then typically they'll hire architectural firms for the larger projects or the larger buildings that are outside. Something that we find common on university and college campuses is someone in a sustainability role, like a director of sustainability. That person is a key voice in terms of making sure that water conservation is front of mind when designing new projects or renovating and retrofitting projects. And then universities are also much more likely to embrace things like sensor technology and power harvesting technology that you'll see here in a second. Universities tend to be much more concerned about the public face of their facilities, which is why they spend more money on things like their washrooms, because washrooms are typically the most visited room in a facility outside of the lobby, particularly in areas where administration might be meeting with donors or alumni that are, are interested in donating back to the school that they went to. Some of the things that they're interested in now are going to a smaller fixture, particularly in urinals. They want something that's smaller and more aesthetically pleasing, and concealed flush valves. So now flush valves that are hidden behind the wall that provide that much cleaner, more attractive appearance than an exposed flush valves would. Certainly college and university students are still prone to vandalism, perhaps not at the same rate as grades 6 to 8. But it is something to be concerned that you'd still want to include robust products that are resistant to vandalism, like any commercial washroom.
I think it's just one comment as you're kind of showing that concealed small wall box, like that little 4x4 faceplate. Aesthetics is an important aspect of design, but so is maintenance. So one thing to be considerate of if you are doing a small faceplate like that, make sure that you have a chase or anything like that, which is not as common these days to have that, person access chase. So just be cognizant of that in your layouts of your design.
Yeah, actually, that's a great point, Zach. That small plate there is certainly a pipe chase type design. Some of our older universities, some of the older buildings of like York University and Brock University, they have pipe chases in behind all of their washrooms. So that's what you would see there. That's becoming quite a bit rare. In fact, in some cases in Brock, they have great big rooms behind each of the washrooms that are a joy to work in. Again, many of the same concerns as K to 12 from a design perspective. Facility managers are typically responsible for the entire campus. So that could be, dozens and dozens of buildings. So that ease of maintenance is really important to them. They don't want to have a collection of different types of products scattered across their campus. Much like in K to 12, they're stuck in their old ways. They've found something that they like and they don't like change. So really explaining to them or demonstrating them the value of moving to a more advanced product to make their lives easier ultimately is something that's really important. Something to consider here, York University now, just in the north end of Toronto. In fact, it's still ongoing. It's been an ongoing almost 4-year project now at York University, where they're completely gutting and upgrading all of their washrooms across, I believe they have 3 campuses, definitely 2 campuses, but I believe they have a third. All of their campuses are upgrading to new technology. What they had historically were both manual faucets, manual 2-handle faucets, and manual flush valves. In both cases, they're removing those and upgrading them to sensor activated technology using solar power. So the solar power of the washroom is an exciting option for them to use because, again, like we touched on a little bit ago, solar power using the lighting in the room doesn't require new electrical run to all of the fixtures throughout some of their older buildings from the 60s. So in terms of the water closets and urinals, they've all gone to a low flow technology. So in some cases, they were using what does 3.5 gallons per flush translate to?
Oh,
Upwards of 15 liters. 15 liters of water per flush in a lot of their washrooms. They've not gone to 4.8 liters per flush. Their urinals are down as far as 500 milliliters, so half a liter. So that's a dramatic water savings right across the campus. And then their manual faucets have all been eliminated and they've gone to a sensor activated solar. So the solar allows for much extended battery life, 3 to 4 times the life that you would find. A lot of the same benefits that you would find with hardwire technology, except now you haven't had to run new electrical. So now it's a single trade installation. A lot of universities I found in Ontario particularly are quite fond on anything that they can make, anything that they can do to make plumbing a single trade installation or maintenance. In one of the universities I've worked with, they had hardwired flush valves, but that meant that whenever there was maintenance to be done in those flush valves, they had to send a plumber and an electrician to maintain them because they needed the electrician to work on the electrical side of things and the plumber to work on the plumbing side of things. So as they're now upgrading and retrofitting, they're going to something they're going to solar power technology so that they only need to send a plumber to that location as opposed to both trades. Jump into some of the product preferences that we find in these different worlds. In the K to 12 world in particular, you'll find a lot of junior toilets or juvenile toilets that have a 10 3/4 inch rim height. They're quite low. Flush valves are typically not popular with this group. They are certainly available and something that can be mounted on a juvenile toilet. But a lot of administrators have found that the flush valve technology itself actually spooks the children when it flushes after they've used the toilets. In a lot of cases, those juvenile toilets are installed in the classroom, so they like to stay with a tank type juvenile toilet. However, if you're looking to keep things common across the facility, you can certainly install a flush valve on a juvenile toilet. Something else that can be applied to vitreous china is what's called a hydrophobic glaze, which is a special glaze that coats the fixture itself that repels liquid. It actually, you'll see liquids and oils tend to bead up quite high on the fixture itself, and they slide off with little effort. They also inhibit the growth of germs, bacteria, mold, anything that might grow on that fixture to make things less hygienic. So some kind of a hydrophobic or oilophobic glaze is something that's really preferred. It works exceptionally well in education facilities. Flushometers are typically the go-to design everywhere else because they provide that reliable, consistent activation and flush throughout. They're much more vandal resistant than, say, perhaps a tank toilet would be. In the case of new construction, it's great to go with a sensor activated technology just because it makes the user's experience more hygienic. And actually, as we talked about a little bit earlier, makes the maintenance side of things quite a bit easier. If it's new construction, battery or hardwire is really the best way to go, unless there's a specific design reason not to. And then in retrofit applications, you have things like power harvesting that you can use, like solar powered or turbine. So if and one more point, just touching on, typically they're not within the scope of the budget for a lot of elementary schools, but I mean, in a perfect situation, if the budget allowed for it, concealed flushometers would be the way to go, because that would be something that would be even more vandal resistant, particularly in those middle school grades. Flush cells typically have two different types of metering technology or activating technology. There are piston activated flush valves, and there are diaphragm flush valves. And both of them are really application specific. And through our experience, we found that the diaphragm flush valve is the ideal choice for 90 to 95% of the installations. They certainly last the longest in terms of service life. They're most resistant to water quality issues, and it's really a super simple operation. However, in some cases where there's low water pressure, for instance, if we have schools that are operating on wells, which there are a number of everywhere, if a school is operating on a well and it has lower fluctuating water pressure, the piston valve is a great solution for that. It operates at much more consistently in the low pressure range than a diaphragm valve will. However, piston valves tend to have much lower lifespan because that rubber gasket that you can see around the outside of the piston valve there is moving up and down, as the name suggests, in a piston with every single flush activation. And once that rubber gasket has worn away, the valve fails in a run condition and will continue to flush until that valve is shut off and the piston itself is replaced.
Well, and the other issue that you highlight there on clean water conditions, sediment on the actual the trigger activation at the bottom has potential, depending on the manufacturer. Some manufacturers have like a cleaning wiper to clean after every activation, but you know, sediment can certainly get in there and affect it. One thing I wanted to just build an understanding of is in terms of actual numbers. What is, say, the low minimum pressure range for, say, a diaphragm? You know, is it, you know, 40 plus? Is it 30 plus? And is it more in that 20 to 30 range where you should really be thinking about piston?
We define we have a 25 to 80 as the CSA standard, which works well for plumbing fixtures. That tends to actually match with the diaphragm valve as well, 20 to 25 psi. But that's important to remember that that's when it's flushing. So when the valve is open, sort of a dynamic flushing situation.
When the valve is open, right?
Not static. If we go back to your fluid dynamics classes, when you think about it, when that valve is closed, your static line pressure is going to be comfortably 65, 60 psi, whatever the building is set for. But as soon as you open that valve, if there isn't enough flow to replenish it, due to line size or obstruction or whatever that reason might be, the pressure will fall off and the fixture won't flush properly. So when that valve is open and running, a minimum of 25 psi. Piston valves, we've seen them operate even as low as 15 psi quite happily. So it's also the choice of valve that they use on board ships for the same reason, because they do have lower pressure, lower water pressure systems. So did that answer that?
Yeah, perfect. Thank you.
Yeah, cool. Faucets, again, in the education space, by far in any commercial washroom, it's the faucet that's actually the most unhygienic fixture in the washroom. A lot of people think it's the toilet, but surprisingly, the toilet gets cleaned so often and the faucet's often overlooked. So sensor activated faucets give you that opportunity to not actually have to touch and interact with the faucet. So manual faucets are just a breeding ground for germs. So, excuse me, sensor activated faucets offer the opportunity to take that out of the equation, along with some of the other advantages we talked about as well, in terms of having an automatic shut-off feature that can be incorporated into them. So, and then they can certainly go, sensor activated faucets can be employed beyond the washroom itself, particularly in cafeterias and food service areas. I know a lot of kitchen design tends to fall back on those manual activated valves, either a knee valve or a foot valve. But again, being mechanical, being subject to the constant regular force and abuse, going to a sensor technology tends to has proven to be a much longer lasting technology requiring less maintenance. Faucets, again, we've talked a lot about student vandalism. It seems to be a common thread throughout. Um, Commercial sensor activated faucets will typically have locking spray heads or aerators, requiring some kind of key to remove them, either below deck or completely enclosed electronics. And any of the cabling or wiring that feeds to them should be armored so that it's resistant to the students grabbing or pulling it. This is one of those situations where some kind of a skirt or a wrap around the lower portion of the lavatory is really a handy way to help protect any wiring or technology or even the supply valves to the sink itself. It's that out of sight, out of mind design philosophy that works. Here we go. There's my button. Sink material is something else. I mean, certainly white vitreous china is by far the most common thing that you'll see in a lot of schools. It's non-porous, resists mold growth. It's very, very common. But some of the other ones that we're starting to see are molded sink material, so molded stone material, which again, like vitreous china, resists mold, mildew, and bacteria. But it tends to be more robust and more repairable over its life. And it doesn't have tight seams in that require getting into them with a scrub brush to clean. So a molded stone technology is a great solution for a school application. You see those in a lot of those multi-station lavatories that we touched on. The other neat thing about it is, like I mentioned, it's repairable. If vitreous china is damaged, then and you're replacing the entire fixture, whereas some of these molded solid surface technologies, if a student chips or damages it, you're actually able to repair it at site to a near flawless finish, which returns it to its original condition. High efficiency plumbing fixtures is really something that should be considered in any kind of high traffic washroom experience or washroom environment. Overwhelmingly across North America, we have a shortage of water supply, either due to a lack of water in the environment or aging infrastructure that really just isn't able to keep up to the demands of what we're building. I mean, you certainly see the shortage of water through the Canadian Midwest, through the prairies, through to Alberta. And then conversely, the lack of infrastructure somewhere like in Toronto, where we're right beside Lake Ontario with plenty of water, but we don't have the capability in either the city's infrastructure to treat and distribute that water, or particularly in the old parts of the city, we don't have water mains that are sized appropriately for the construction that's happening in the high-rise world. So conserving water is something that really should be top of mind in anyone's washroom design at this point. Never mind the financial piece, with water rates continuing to increase year after year. Schools do use a vast amount of water between their cafeterias, washrooms. HVAC systems are quite, cooling towers in particular use quite a bit of water. Sports fields and landscaping, not as common in Canadian schools, but certainly down throughout the US where they use a lot of sports fields with irrigation. There's tons of opportunities to design our schools so that we're saving water. So sort of the standards in terms of high efficiency toilets and high efficiency urinals, those are what we should be looking for. So anything tagged as high efficiency toilet or high efficiency urinal, as we talked about before, water conservation has fallen, or sorry, water consumption has fallen dramatically with older plumbing fixtures using 3.5 gallons right down to now where we're at 1.28 and in some cases even 1.1. A high efficiency toilet will use less than 1.28 gallons per flush, so that's 4.8 liters per flush. And then urinals, 0.5 gallon or 1.9 liters per flush. But again, you can go quite a bit lower than that now and have equitable performance to what we've had in the past. And then certainly hybrid or water-free urinals are an option as well. You're able to take away that water per flush every single time. It can certainly be used in school applications, but we find that they're not ideal. Just from the challenges of the abuse that they would stand up to, more less so than sort of the traditional urinal type design. A water-free urinal uses some kind of a gel cartridge to stop the odor from coming back up into the washroom, as opposed to having a trap that a traditional urinal would have. And then some of them are also hybrid, so they use some kind of a water rinse on some kind of regular basis to prevent calcification in the drain pipes beyond the urinal. I will offer the caveat that I always do with water-free technology. It really has to be employed on new construction technology where you know exactly the drain slope and drain sizing behind the wall. And that you can be assured that all of the plumbing drainage behind the wall is all plastic, because metallic systems are not able to carry away that concentration of urine without rusting out. Copper, for instance, copper drainage will wear out extremely quickly with all that uric acid going through it. And then retrofitting faucets is certainly something that's available to all of us in any of those designs. We touched on that in the case of York University, where you're able to retrofit old washrooms with new technologies, in a lot of cases without even the need to run electrical, through either battery or some kind of power harvesting technology like solar or turbine. Renovate or retrofitting an older washroom improves accessibility, hygiene, cleanliness, conservation, and as we touched on as well, makes the facility management lives a little bit easier. We talked about touchless faucets. They operate for a predetermined time during an activation. There's typically two modes that a lot of them have. They either activate for a set amount of time and then turn themselves off, or they activate when hands are present. And those run times can be adjusted to help move people through the washroom environment more quickly. And then to touch quickly on alternate technologies, and that's power harvesting. So that's where, like we talked about, solar power or turbine technology comes in. Both of them have their advantages and disadvantages. Turbine technology, for instance, you're inserting a little power generator into the water flow. So now you've inserted a moving part in there that will wear with time, and also has the ability or the possibility of becoming clogged if some kind of line debris comes through. Turbine technology tends to rely on proprietary batteries that are not easily or cost effectively replaced. And one of the things that happens with turbine technology in a building like a school where it has seasonal occupancy is that during the summertime, those batteries are not being charged because they're not being regularly activated. So one of the things that you should look at in terms of choosing some kind of power harvesting technology is the life cycle or the occupancy cycle of the building. So if it's going to have long periods where it's not occupied, turbine technology really isn't the best solution. And that's where something like solar comes in. So solar technology now has no moving parts in the water stream and is able to generate power based off of the lighting that's in the room. And it will even function happily on LED lighting and occupancy lighting. So it takes somewhere about 90 seconds for that capacitor inside the head to charge the faucet to activate, which is typically plenty of time for a user to come into the washroom and activate that. The advantage there is that the solar power uses standard batteries as backup, so AA batteries as backup. So if they do need to be replaced, they're easy and cost effective. And then looking at terms of occupancy, those batteries aren't running down during the summertime when the building itself is empty. So solar has some advantages, particularly in schools, over turbine technology. And I hope everyone benefited from that discussion. Certainly, I hope we've demonstrated that K-12 and higher education facilities have some pretty unique challenges that are a little bit different than most, a lot of those, revolve around the high use, the abuse, and the challenges that maintenance property, sorry, facility managers have in maintaining their properties. Um, they certainly have unique challenges in maintaining a multi-campus or a multi-school facility and larger school boards. Sustainability, as you saw, is important. It tends to be a more important conversation at the college and university level, but it's certainly something that can be brought into design at the K to 12 because we're not creating, or I shouldn't say that we're running out of water, but it's getting more difficult to find water and distribute it effectively to schools, especially as water becomes more and more expensive. School boards are required to pay those bills.
Yeah, I think that's the big.
Thanks for your time.
Yeah, like that's the biggest part, right? Like the cost of the water is going up, similar to the cost of repair parts is going up. The cost of hours for work done is going up. So having a product that lasts a longer time certainly is going to be an effective use of the budget comparatively. I just want to take a couple of minutes here and show how you can find the products that we talked about today. We'll also have Will keep an eye on the chat in case any additional questions come in as we finish up here. But yeah, thanks for joining us, everyone. Thank you, Will. That was a great discussion. Always appreciate a deep dive into an application. I think those ones are my favorite. If this is your first time joining us, thank you for giving us a chance and joining ATS University. I mentioned that you can find our previous recordings. This is atspec.com. You can go to the Architects and Engineers tab, go into a Learning Hub, and find all our previously recorded webinars here. And you can view all the different ATS University sessions, designing for hospitality that we did. We had a great presentation on dog wash stations that are now launching and getting popular. Obviously, the MIC control valves for ACVs, large volume hot water, all sorts of different discussions, various topics and applications. Again, if you've not heard of ATS before, we are a free login, so not quite subscription service, but you do have an account. Your service is paid for by manufacturers like Dobbin Sales and Sloan that we learned about today. So you can log in, share projects within your firm, and get all the great features that we have, including one of my favorite new features, these ATS templates, where similar to today, how we were discussing an application, we also have these templates that help you get the right product for the right application in as few clicks as possible. That's always our goal in our design. So you can see if you have a new high traffic area you're doing an airport, you could simply download this catalog, get a nice brochure, or you could click this button, start a live project with it. However, personally, my recommended way would be log in, and then on the dashboard, you can just go to this new project button. We have a few different ways that you can get started. Everything is just basically select and start building your folder. So we have our projects, we have quick specs, and we have masters. You may be asking yourself, what is the difference between those? In essence, a quick spec is just our base open library of products. There's no building code applied. There's no rule engines applied. It's just here's product, configure it. And it's very quick and easy. If you just need a singular, let's say basin or faucet, let's say we need a faucet. We could type in faucet, get into our product selection. If we know the exact model number we're looking for, we can type in our EFX 200, or we could use our search categories here. Or if you have pinned your favorite category, it might show up here. Or you could also search in this for a category that you like. Once you're in the category, you can then refine, filter, configure all of your different options. So if you wanted that metering faucet that we talked about, you could use our filters here to search for a metering cartridge, and we could toggle that and it would filter this down to just the metering. If we want, this EFX 200, we can select this. If you want to confirm if this is the product you want, you can hit the spec sheet and view the manufacturer's spec sheet all on the SpecTool. And of course, you can either configure it yourself if you want that low flow version, or you can select most popular and it'll pre-select some of the most popular options for you. Add this to your product, or add this product, and it'll start adding product into that folder that we set up. You can also, we have a new feature. You can see product catalog here, which allows you to start viewing these categories before even creating a product folder. So before creating a quick spec or before creating a project. The project is going to be slightly more detailed than the quick spec. You're going to put in a title, a location. The location is going to help us apply the appropriate building code. You're going to select your application and your bid date, which is going to help us recommend the right product and keep those products up to date while your project is out for bid. So you can see I've got a bid date here of 10/10/24. So up until October 10th this year, my project would be kept up to date. If Sloan changes a model number or discontinues a product, you get a notification from the system that tells you, hey, you should log back in, double check that educational project that you started and make a selection. So one thing I want to show you here, I've got obviously blank slate. I can go to this add product button. I can go to this plus button and go to that create new drawing, which is going to take me back to my categories here. I could then walk through and create my selection. I can select my toilet, my flush valve, my seat, everything like that. But let's say I've got a deadline coming up. I've got a meeting at 1 and I've got to do a presentation on some plumbing fixtures to Will. If I've got a master for this application already, so if I've set up, say, my engineering firm XYZ's school board standard, I could simply go in here, drag and drop over, and have my firm's pre-approved selections. And I'm here to help you out with getting those masters set up. Or I can go into the ATS templates, which we discussed earlier, kind of like an ATS version of your master. So you can see we've got educational facilities master here. I've toggled this to show of my current building type. And I can go into, my ATS template right here. I can go to the bathroom suite and I can start copying over some fixtures. So if I know that this is going to be, exposed, sensor activated, hardwired fixtures, I could toggle these. We're going wall hung on this one. If you needed a child height as well, we could make that selection here. Let's go for a urinal. We'll go for a multi-lav. And then, of course, we'll go a couple of sensor operated faucets. And we may have a universal bathroom that we need a wall hung barrier free for. And if you need partitions, we've got partitions in here as well. So if you're on the engineering side, you may be looking for more mechanical equipment. I'll show you how you can find that. If you're on the architectural or interior design side, you may be looking for more partitions and accessories. So you can see I've just checked the box, grabbed this to copy the selected drawings and drag them over and they populate. From here, if I wanted to, say, adjust my flow rates, I've got 1.28s here. I could go in and hit edit, and I could change either the name of my fixture tag. If people call it P1 versus WC1, you can do so. If you want changes to the 4.2s, we can make that change. If your output spec requires a true mechanical override, you could select that instead. Or if maybe you're going more budget oriented, you could search for, say, the Regal and go with a Regal 111 instead of the Cadillac Royal flush valve. I can cancel this anytime and go back to my project, or I could hit complete and finish off my selection. You can see ATS always tries to put a chain of fixtures together. This is what we call our fixture chain, where you get all the appropriate accessories from your toilet to the seat to the flush valve, carrier, power transformer. Now, you may be using other manufacturers, and that's fine. You can always delete out the manufacturer that you don't use. And we're going to soon, in the near future, for certain firms, have an alternatives feature where you can add in, say, the alternative to your Sentoko seat. So now if we need to add in some additional products here, again, we're doing a whole new build. Maybe we'll go back to our templates. I want to show you how quickly, beyond just the fixtures, you can actually build out, get this 90% of the way towards what you need. So let's say we've got a classroom area. Do we need all these? We'll say sure. So we'll select all, copy this into new product group. The other one we may have, this is a high school. We may need a science and lab area as well. We can go and select all. Maybe we don't need, on this particular project, we know our architect prefers our eye wash to be over the sink. So we can just do that. We'll grab these and drop that into a new product group. And of course, you can jump back and forth to various templates or a combination of ATS templates and masters. So I could grab a single fixture. If I just need the single water heater, I can grab this and drop that in there. And then go over to my masters. Maybe I know that I've got a firm drainage master all set up. I can go into my drains and specialties. If I'm too far ahead, I don't have all the different drains decided yet, I can copy all of them over and then refine it after we've reviewed our drawings, or just a single placeholder, whatever it is you need. Of course, you can get backflow, you can get trap seal primers, all the other pieces that you possibly need to round out your selection. And of course, you can drag to put that at the top. We can put it just below our water heater or all the way down at the bottom. So this is our Master's Quick Access drawer. Great new feature to help build out a complete project in a matter of minutes. Once you're done, select all the drawings or just select a singular drawing or just select a singular product group. We've got our fixtures here. We've got our classroom, and then we can go into our bathroom suite. If I just want to print off the bathroom suite right now, I can check this, go to my download button and download it in a submittal format, schedule, long spec, short spec, manufacturer spec, get the Revit for the entire project, or a CSI 3-part spec if that's what you need. So we can obviously generate all those documents. And I know I'm running a little bit long over time already, so I appreciate those that have stuck with us so far. Just about done. If you haven't seen our formats before, this is our ATS submittal format. Obviously combining multiple manufacturers onto one page. You got the manufacturer's spec format as well, where you get the detailed manufacturer spec for these products. We've got fixture schedules. So this is going to give you one version of our fixture schedule. You can get the all caps version as well. Copy and push this directly into your CAD. I'm going to try to move this up here for a second so you can see that within this schedule, you get different tabs for different categories. If you had backflow, your backflow would be a different schedule. And then into our CSI format here, if you are using a 3-part master spec format, this will align with that. And you could copy and paste your products right from there. So we can go, yes, I need this flush valve. I'm going to copy, paste, or just edit this if you want. All of our formats are open and editable. Or if you're more familiar with we call our ATS long spec. Here's our ATS long spec here, where again, open and editable. You can take your full Sloan spec here and pop that into your drawings. I did want to show what this looks like as well. I downloaded this ahead of time. So you can see, all the different categories that we talked about. We got our science lab, we've got our general classrooms, the drainage, the bathroom fixtures, and all those different formats, including the Revit files for the entire project here. All done, pretty short amount of time, less than 10 minutes to do an entire project here. And of course, we could then go back, edit, revise, do whatever it is we need to customize from the template to your specific project. So if you've not seen that before and are interested in learning more, please feel free to reach out to me, Zach at atspec.com. If you would like a deeper dive on the educational field, and if you have a particular school board that you would like Will and I to help you review, we're certainly here to help with that as well. Will does a ton of those pretty much all day, every week, where he's trying to keep manufacturers updated on school board output specs. So certainly feel free to reach out for Will or myself, and I can help get that coordinated. And if you would like a session in more detail specific for your firm, on the educational sphere, whether it is a AIA accredited version, deeper dive into Sloan, or any of the products that Dobbins has. Certainly happy to set that up with you guys as well. We can do the lunch and learns virtually or in person. It'd be great to see your face again. Well, I know it's been a little while. It was last month when I was over at Dobbins, so
Yep.
we can see each other again, grab lunch, and do a lunch lunch somewhere. Maybe if people are interested.
Anytime. We do have
Um,
one question that popped up there while you were talking.
sure.
Unfortunately, it's from an anonymous attendee, so I can't give credit to the person, but it's a great question. Just read it out so we know what we're talking about. Childcare facility, if we use automatic faucets with built-in mixing, do we still have to have the central mixing valve and a tempered loop? And it's a great question. And I would suggest that it depends.
Yeah, that's
Because
what I was thinking.
yeah, they're both really accomplishing different things. So that central mixing valve along with the tempered loop are addressing delivering water to the fixtures at the appropriate temperature. Obviously your storage tank water temperatures are going to be significantly higher than you can safely distribute throughout your building, throughout your piping loop. And the tempered loop itself is just ensuring that that water gets delivered to the fixture at the right temperature, because without that loop, you're going to have stale water, or cool water, I should say, stagnant water temperatures in your pipes. And that becomes more prevalent with lower flow fixtures. So as the fixture flow rate goes lower and lower and lower, those pipes become stagnant more quickly. So I would suggest that you still need to have that mixing valve to make sure your temperature is distributed at the right temperature. You still have the loop to make sure it's warm when it gets to the fixture. And then the automatic faucets themselves, they would have to have some kind of point of use mixing. So you'd have to have an ASSE 1070 mixing valve there to bring that temperature down to something safe for the user, especially because it's childcare on the scald protection side. So you can either do that with a point of use mixing valve or a faucet that has an integrated 1070 mixer, or more accurately, a 1070 temperature limiter built into it.
Yeah, I think that's the important part is there are faucets out there that just have built-in mixing, and then there's faucets out there that have an
Yeah.
accredited, ASSE accredited 1070
Yeah.
limiter.
That's the key thing. Yeah.
Very careful about that versus just a hot water limit stop that you may be familiar with if you did a lot of showers in, say, the early aughts. Those certainly had a hot water limit stop. That's different than an ASSE compliant mixer. Now, if you do have the ASSE compliant mixer and you have 120 water circulating from your central mixing valve, you could go direct from the 120 to the ASSE compliant. There's different ways that you may wish to do that, similar to PRVs where you need to do a step down. You may want to do that as a limiting factor, especially for childcare, just an extra step of safety.
And yeah, I mean, 120 might still be too high for kids.
Yeah, 120 with the ASSE 1070 point of use mixer potential, but you'd be fine. You may wish to put in, say, a separate tempered water line that's taking that down to, say, 1.5, 110, and then your 1070 point of use. So lots of different ways. If you wish to discuss more, if you have a particular project that you actually need some help on, please feel free to reach out. We can have a deeper dive with you on that. Obviously, you can see just from that answer, there's a lot of different ways you can handle that now. But yeah, thank you very much, Will. That was fantastic. Always appreciate your insight and your discussion. Can't wait to have you back. And thank you all for those jumping on with us. Hopefully you found it valuable and you'll join us again soon. Have a great rest of the day, y'all.
Thanks, guys.